Projects like this, you can't do only with one technology. Imagine you have high buildings where if you're using terrestrial laser scanner, you can't bring it up there. So you have to rely on the drone data.
We fly manually, we do a lot of orbits, we do ground images, and we are putting everything together to bring beauty to accuracy.
This looks visually nice and you think like, oh, maybe a gaming way or something. No, but it was proper research. So we did like very accurate data, which historians and researchers use as underlay based on those data.
It can also be used, of course, with the construction industry, the architect. They want to show the client how it may look in this place, not just as a CGI picture.
Then we are taking you also to high peak of the mountains for the virtual tours for people which cannot walk there, so you can get on any place in the world. Also bringing you underwater. This was purely done with photogrammetry. Coming further, we can 3D print it because it's referenced. We know the scale. And bringing it into more gamification, you can bring the life to those objects.
It will have a huge impact on how we do games, how we do VFX, also for marketing purposes, like displaying your restaurant or shop. As we see the future with this technology is the combination of actual laser scanning and photogrammetry with, for example, Gaussian splat. Imagine you can walk freely in the video, basically, right?
Everything is possible to get digital. Any place in the world is possible to get in 3D. So you have the combination of the accuracy and beauty and trying to get this data very precise, but still visually great. My name is Tomas, and this is Michal. We are from Overhead 4D company, and we are going to show you a little bit more about the combination of laser scanning and photogrammetry and different use cases.
We got together because we use the same technology, we use same workflows, but our outputs are quite different. We use laser scanning, we use photogrammetry, we process them in the very same softwares. But Tomas is more into cultural heritage, more into art. He studied design. I'm more technical guy, so I was doing more scan-to-beam jobs. And let's build documentations, 3D mesh models for visual inspections. And for the past 2 years, I think, or 3 years, almost every project that we did together. So we just figured like, why not to merge? Like, why not to do it together if we are always doing these jobs together? So we joined or merged in like 2 months ago, and we decided to bring beauty to accuracy.
Yeah, so you can guess who of us is beauty. So you can see on the picture on like 100,000 images for one area combined with laser scans. And you wanted to mention the points which are important for combining and making such a huge areas, and why not doing it only with the lasers?
Yeah, I mean, if you look closely, all those like white lines and points, this is not point cloud, this is actually the positions of camera that we took images from. And as you would expect, this is not something that can be done automatically. So what we usually do is we fly manually, we do a lot of orbits, we do ground images, and we are putting everything together. So the job like this, where you need to map the part of the city in very high detail, is not possible to do only with laser scanning. It's not possible to do only with another photos from the automatic grid plan. You gotta combine many different workflows, and yeah, that's what we specialize in.
Yeah, as you can see, projects like this doesn't end only in the point cloud, but most of our projects are finalized in mesh, and the reasons are different. Like we do underlays for architects which are preparing some studies, but also we use those data for final visualization. So you have the combination of the accuracy and beauty and trying to get this data very precise, but still visually great. just to understand what we talk about, it's that like almost the entire area which you see on the picture is captured by the drones, lasers, and the highest building in the middle, it's a model from the architects. So it helped us to combine two different worlds and to showcase the possible clients or people which would like to get the apartments also to see realistically what they will see from their apartment. So it's not just like traditional way that you get a picture and you can guess that like from 5th floor to 25th floor you see always the same view. So this is like very, very accurate.
How much data were there?
Like in total, we said around 100,000 images, a few thousand laser scans, but we speak about dozens of terabytes of data, just like in collection. And we would like to show you also a little bit like how to do it and what is very important when you are taking the images. So as you can see, for example, here, it's not just about like capturing anyhow. It's great if you have certain structure, if you have a skilled pilot. Not all of these can be done automatically unless you are using, for example, like SkyTeo drones, which are autonomous and can pre-scan the area and then calculate the distance. But still, in a lot of parts of the world, it's not allowed to fly fully automatically. So here we have like manual flights. And
this actually looks like the drone pilot has OCD with the with the camera positions and flying patterns.
Yeah, exactly. So as we said, those data are very important also for the accuracy. So there are many topics of control points, ground control points, right? And there are also advantages like why to combine those two technologies.
So one question, and just so you guys know as well, we do have the Q&A open. There's some unique things in here I think that a lot of people have had questions about, and they asked if we could take some questions. So you guys can submit those through the app we've been using if you'd like. One question would be, you guys are looking at the combination of photogrammetry from air, from ground, from terrestrial scans, and you're doing it of a very large area and very high detail. So what do you have to do control-wise, and how do you integrate that?
Yeah, we have heard like this several times here, that the control of the data and basically all the workflow, the survey control is very important. So one advantage, if you are actually combining the laser scan with photogrammetry, is that you don't need to control it twice. It's enough to control the laser scans. Once they are in control, you can process it in, for example, we are using capturing reality software. You can combine them in this software, and all the photogrammetry data will align and register with the controlled laser scans. So you only need to control one set of dataset, and the rest will just stick to it.
Awesome.
Yeah, as we mentioned, we would like to share also some of the key points. People which are using photogrammetry are definitely aware of them, and they know what that means. I don't want to go too deep, but there are multiple things which you have to set up to don't get blurred images as shutter speed, ISO, to don't get really noisy images, because all of those points are influencing the result. So getting bad input means getting bad output. So you can't save it later. Therefore, it's important to take care. But one of very important points which people don't like to use is the last one, the image quality set to RAW. Why people don't like it? Because it's a huge file. So if you shoot to JPEGs, you can, for example, with 40 megapixels camera, you count with 10 to 15 megabytes. Raw data can be 40 to 80 megabytes. So you count with 8 times more. And yeah, that gives also a question like how to store the data, how to work with them. But as we want to show why, there are like simple showcases. You see the same image captured like in RAW, and then when we are using D-Light. So it means like we are taking the information from the overexposed area, but as well from the shadows. As you can see it on the tower, this is like on one side fully white or like overexposed, and then the other one you see the features. What does that make in the final model? And this is the result. So on the left side, you see, okay, we wrote it raw, but it means like it's without using this daylight or using JPEG directly. And if you fix the image, if you use and take the informations which are hidden inside, you can get pretty smooth result. And of course, we are speaking about the combination of laser scans. So you might think like, okay, but laser scanner will fix it anyways. But imagine you have high buildings where if you're using a terrestrial laser scanner, you can't bring it up there. So you have to rely on the drone data. And therefore, this is like very, very important. But there are also like many other points. Seeing it also in from like other way around, you can see like bad image because there was a lot of light, a lot of dark. And if you try to like use the information from a JPEG image, that's the first one, you just pull up the gray color, or actually like you're just making it darker, but you are not gaining the information unless you use raw and you see how the informations are captured and are hidden in that image. So this is very, very, very important to combine it. So that was a little about our training session. If there is any question, like feel free to jump in anytime. We're happy to answer. And now I will slowly move to some showcases and also visual outputs, because we had here a lot of great showcases with very technical use case. And here we go more into part of creativity or other application use cases.
So we got another question.
Yeah.
So what's the registration tolerance and accuracy between the terrestrial scans and the photogrammetry data when you're doing that combination? How do you track the quality, or what's the accuracy?
So generally, like the terrestrial laser scanner has the highest priority there. So if terrestrial laser scanner is registered correctly, we bring it to the reality capture software or any other softwares in the same quality. So exactly as you have the inspection or registration done in other softwares, you bring it in and it's there. You bring it as exact and the software will not move it. And the photogrammetry is actually merging over those points. You can also make a ground control points where you already can register them inside of the laser scans, and then you bring the same points into photogrammetry. So it's actually overtaking the quality of the laser. You only get like in the higher areas maybe less points, let's say. So maybe the density is different, but the quality it's then like taken from the scanner.
The difference is that when you try to control the data from drone, you are always getting error because it comes with the technology of photogrammetry, right? You always have this few centimeters error on the XY and even more on the Z, right? So, but this all can be eliminated with combining it into a laser scanner, exactly as Tomas said, because it doesn't rely on the ground control points. It relies on the actual data on the laser scans.
And so one of those key differences is you're not processing or registering the scan data separately from the photogrammetry data.
Well, you do laser scans separately as first. This is your base. Then you import it into reality capture software, and then you do alignment with the images.
Awesome.
But the laser scan data are untouched, like they are fixed.
Yeah. And what you could see here on this example, it was a castle scanned entirely from interior and exterior. And here we can see also the outer shelf of it. It's again like projects like this, you can't do only with one technology. You need the combination of both of them. And interesting part about this project is that that was done also for technicians, for research. So we need to get like cross sections through the building, and historians were discovering where are possible rooms which are missing, because like some informations are saying that this castle is missing 40 rooms, and it was the richest person from Poland. So they still expect there might be something hidden. And like this, you get this technical output, accurate output, and you start to cut and measure where are possible holes or gaps without any entrance to see whether you can really dig there without like destroying the building like just by guess. So within this data, we managed to find around 17 places where they start to dig and check whether there is really something.
I haven't seen this one. I'm really proud of us. It's a great project.
Yeah, and going even a step further, and now we will go also more to the research than to a scanning section, is that you can see from one side it's like captured data, and then the right side, my right side, your right side of the picture is the reconstruction to the 16th century, and also. This looks visually nice, and you think like, oh, maybe a gaming way or something. No, but it was proper research. So we did like very accurate data, which again historians and researchers used as underlay. Based on those data, they do the research sketches, something like architects. Like architects now, they are building new buildings based on some data. So they're making this reverse reconstruction and starting to combine again those two worlds. So we have existing place, we have scan of the ruin, and overlapping it with the new data. So you can really see something what was there just like a few hundred years ago. And in most cases, people are just listening about it and not seeing it. So therefore, it's great. And as Michael also mentioned on the beginning, we are doing like laser scanning, photogrammetry, but also developing the applications for those kind of clients or education. And here you can see how the data can be used further. So it's again not just about having it in 2D or having a picture, but really bringing it back to people to see it and to try to, that they can play with it. And here you can see the AR station points on the castle. And actually, it works like this, that when you scan the QR codes, you get the application, and you can freely walk on the castle, see the ruin itself. You can take pictures like normal usage of the phone until you find the QR code or the target in that case. And once you scan it, you get it green, and then you can see the overlay. So it's like real feedback for people that it's not just seeing it somewhere on the screen, but they can really like walk through that and see it in this mixed reality, I would call it in that case.
This is the showcase for the castle, but it can also be used, of course, with the construction industry, the architectures, like if they want to show the client how it may look like in this place, not just as a CGI picture, right?
Yeah. That's really cool, and I think that's a place that a lot of people haven't taken that further step yet. One question is, what kind of hardware and software are you using in these processes?
A lot.
Yeah.
Well, we use. I don't want to like drop brands, but we use Leica equipment for laser scanning. We use different kind of drones. We use cameras for ground images. Then we put it all together inside the capturing reality software. And yeah, there is exactly where magic is happening. Like if we always get these questions about whether we use Pix4D or whether we use drone deploy and this stuff. Those softwares are great, but those softwares are great when you're doing automated missions. When everything's set on your drone or your applications. The drone does its job, then you upload pictures to the software, and the software, again, does its job. But when you are trying to combine different kind of data from different sensors, and even combine it with the laser scanning, then you won't get any help from these softwares. So that's where I call it like a Photoshop of 3D. That's where reality capturing software is coming, where you can do basically anything, right? The learning curve is quite steeper than in other softwares, but you can really do basically anything, and you have total control over the alignment, processing, optimization, and these stuff.
But just to add on, of course, this is like to gain the data, but going into the application and like optimizing data and creating the past log of it, you need like standard like modeling softwares for 3D, and then using game engines to develop the applications. So there is really much more than just like getting the correct 3D data. But I like the point what you mentioned that we are showcasing it on a castle. It can be like any side, it can be technical. We had here already multiple showcases of AR in the buildings. So we just decided to show it from a little bit other side, that people can also see that we have great technology, which all of us are using, but this technology is not just there for one industry. You actually you have open doors to all of the industries, because the pipeline, it's the same. So.
Yeah, and there are still many industries that doesn't even know yet that they will need it and use it in the future.
Yeah, and as we mentioned, we decided to showcase maybe more unusual places or unusual use cases for this conference. Then we are taking you also to high peak of the mountains, where we were doing applications for the virtual tours for people which cannot walk there. But all of this it's not like a virtual tour with Matterport or 360 cameras, but it's really like free walk possibilities. So you can get on any place in the world, even though if in reality it doesn't work for you. Also bringing you underwater, so showcasing that the technology here, it's like with laser scanner, for sure not. There are like sonar, other technologies, but this was purely done with photogrammetry. So our partner, Ocean Discovery from Sweden, they are focused on underwater photogrammetry, and they were, in that time, in year 2000, taking 20,000 images, not in that year. They had to dive there over 10 years to gain like 20,000 images to get the possibility to reproduce a model like this. Nowadays, they have like a small RAW, and they just dive down there and do it in 3 days. So the technology is helping everybody. But here you can see also like bringing places from inaccessible areas to people that they can play with it. But that's the visual part. But again, coming further, we can 3D print it because it's referenced. We know the scale. So this is in certain scale, but you could print it one-to-one. But as well, continuing with the research, it was a great underlay for technicians to see the measurements, to cut the model, to puzzle and start to build the past look of the ship. So it's a research, it's a material for research. And like this, you can get to any look of any object which doesn't exist anymore. And again, bringing it into more gamification, you can like bring the life to those objects, and you can let people play. So here we did another thing, not showing it just as a video, just as a movie, but again, interactive. You can trigger, you can rotate, you can be part of the immersive movie, and you can choose your perspective. And yes, we can bring it to the city, we can bring it anywhere.
This is something how the future of movies will look like, where you can just interact with the movie, see the situation from the different angle.
Yeah.
Another question real quick.
Yeah.
How do you manage the ambient light issue during capture process?
Yeah, that was actually part of the first section where we showed this delighting. So there it's very important to, if you have a bad lighting, that you don't manage to make it with overcast, that you have just ambient shadows, which outside it's not always possible. Then you have to take the pictures in RAW and delight and play with those images to get the information from the shadows. Then with that amount of images and multiplying, you are kind of overlaying those shadows and losing them. Of course, somewhere stays the sharp line, but this normally it's retouched manually, or another materials and other objects help to hide it. So
what about for interiors? Do you use flash with pictures? Do you bring in lighting, or how do you deal inside?
Yes, mostly there are multiple ways. You can bring in lighting, you can use any kind of flashes, but the best what you can use is the ring flash. So it means like you have the light around the lens, and then it means like every shot is without any shadow, so it doesn't drop the shadow. It sounds weird, but who never tried it, it's hard to imagine, but the light from around the lens help you to make like super flat image. So you don't see any shadow, you don't see any depth. It looks even sometimes wrong, that you don't want those images, but actually those images are the best for photogrammetry. So in interior, it's easier in that case that we don't have a changing lighting. So you just turn on some ambient light inside, and then you start to capture with flash.
This is what you can see is you can play it.
Yeah.
This is what you can see is a project with our military customer. He's actually producing this radar equipment and he's putting it in already built cars. Like he's not building cars, but he's just doing the equipment with them. And he wanted to present his stuff in a Dubai exhibition, but it was around the COVID. It's really hard to get these trucks somewhere abroad, right? So we decided to create this 3D interactive way how to immerse his potential clients and leads directly at the expo.
Yeah. And this is also showcasing that the models which we can gain by scanning can have physics on the end. Of course, it's some work, but we don't speak just about like model which is there and you can't do anything with it or just using it as an underlay. But this is like bringing them to life.
And it's not modeled. This is photogrammetry with laser scanning. We just fixed like windows or a little bit of the textures, but this is photogrammetry.
Yeah, and now we will showcase also one like technical thing, which is not super accurate, but it's just as a showcase to see that by changing the sensors on the cameras, you can get on your 3D model also other information. So if I can just reverse it once. So here we used thermographic sensor and we were able to map on top of the real texture also like thermal image, and you can make the inspection of the building. Of course, like if you want to make it proper, you need to do it in the night because that was like affected by the sun, so the information was not correct. But like this, you can also do the inspection better, because originally, like if you take just image and image, you can't really move around and you can't control whether there is a crack, or like you can inspect it. Okay, if there is no crack, probably it's from inside, and like this, you can fully like rotate around and check. So yeah, also
and also if we bring this to the tool, for example, like Nira, where you can actually click on the model and see the images in the high definition, then high resolution, then it's really good for visual inspection and just to see what's going on there.
Yeah, and coming closer to the end, we would like to say a few words about Michael's direction and
Not really. I was bashed yesterday here with my nerve, with my nerves to do nerves and to try to push it on the market. But yeah, that's something that we like need to study. We need to see where that's heading. What can change in the future with our industry. So yeah, I pay attention to nerves, I pay attention to 3D Gaussian splatting. And on this video, you can actually see like the real use case, how it can be used inside the gaming engines. Because like the first arguments when it comes from top of anybody's head is like, it doesn't have physics, you cannot control lights, like it doesn't have too much detail. But on this video, you can see the dragon is, of course, a model, animated model, but all the rest you can see is just from 200 images.
You didn't scan the dragon.
No.
Okay.
So
but we are planning
next.
Yeah, but
he wouldn't stop like just for a second.
Still.
No.
But the site is a nerf.
No, the site is Gaussian splatting.
It's Gaussian splatting.
Okay.
Can you give a little explanation of, because I don't know either, the difference between nerf and Gaussian splatting? I know those are terms that are being thrown out. What's the difference between?
I don't think like we need to get like very deep into technology, but the main idea is like for decades we have been using photogrammetry in certain ways, and we always thought that this will be in the future also just the photogrammetry. But from the beginning of last year, the things started to change. The nerf was like the first step into photogrammetry business with these crazy VFX videos done with nerves and this stuff. And it couldn't even get into market, and it already got like destroyed with the Gaussian splatting, which is totally different approach to like recreating the 3D space or 3D objects. And as you can see also on this video, it will have a huge impact on how we do games, how we do VFX, and all the 3D stuff in the future.
Do you see an application for that type of technology apart from the visualization? Do you see it implemented somewhere in the built environment, construction or?
That's very often also this question that like everybody's, but what's the accuracy? I mean, I don't care for the accuracy because it's not meant for accuracy, right? It's not going to replace laser scanning because both NERS and Gaussian splattings are not meant for accuracy. It's meant for the best visual representation, right? So as we see the future with this technology is the combination of actual laser scanning and photogrammetry with, for example, Gaussian splatting. So the object that we need in high accuracy with high geometry details and stuff, we will do it normally as we have done it till now, right, with the laser scanning and photogrammetry. But for all the rest, for the environment, for the long distance view, then the Gaussian splatting is the way that we can combine with that, and it's giving this perfect perspective to any stakeholder that will use the data.
Yeah, but also for like camera positions, for people which are like recording something, agents for sharing flats, like you can just run with your camera and then you refine the path and you optimize that. So you are just getting like better results, maybe not for industry for measuring, but there are like multiple cases. Yeah, and
also for marketing purposes, like heavily, like use it for just displaying your restaurant or shop and this stuff. This will be like really perfect, and I would be really afraid about the motherboard future with these technologies.
Well, and like you said, one of those differences is you're not fixed to a position. You can really browse the entire environment.
Like feel free in the. I always say like, imagine you can walk freely in the video, basically, right?
Yeah.
Yeah, and just like coming to the end of our presentation, it's we just want to just say it even stronger that everything is possible to get digital, and this is like one of our projects from last year. I need to mention our partners, Virtual Worlds and Zen Art, just to be correct. So we have done it together, and those data are going then for virtual production, and you can like freely move. You can record a movie, you can record a commercial, but you can use them as well for any inspection, for architects, for archaeologists, sorry. Yeah, just end of our presentation, when beauty meets accuracy, and any place in the world is possible to get in 3D. Yeah, thank you.
Great. Thank you, guys.
Thank you very much.